Hello, my dear friends. I'm Shubham from LearnoHub, the free learning platform where you can study physics, chemistry, maths, biology absolutely for free at learnohub.com. So then, let's start. So friends, as you all know, we are studying your ICSE class 10th chemistry chapter number 8, and in this chapter number 8 study of compounds, okay, was quite big, but we have reached the last part, the last compound which we have to study, and the very much important compound, okay, sulfuric acid. Right, so we are going to study in this video sulfuric acid, all the concepts of the sulfuric acid, sticking to your syllabus very precisely, and lastly we will solve some questions also which are being asked in your previous year exam, so that you would get a hold of the questions as well. Okay, so without wasting much time, let's start and let's rock. So again, starting with the same question, why we should study sulfuric acid, and the answer is very much simple. We are just going to see the applications, and sulfuric acid has literally lots of applications. Okay, so I just can't jot it down on the page, okay, or I just don't have that much space to show the images of these applications. So I have just picked some few applications which would be like very much close to us, like just dyeing the clothes. Okay, it is used for manufacturing dyes. In the same way, it is used for manufacturing drugs like medicines, also used for manufacturing fertilizers, used for manufacturing explosives. Okay, so lots of applications. But in the previous chapters which we have studied, like hydrogen chloride and nitric acid, in that we have used sulfuric acid for preparation of those acids, right? Hydrochloric acid and nitric acid. Not hydrochloric acid, but indirectly we are preparing hydrochloric acid. How? By preparing hydrogen chloride, right? Hydrogen chloride gas. So yes, it's indeed used for preparation of acids, other acids like hydrochloric acid and nitric acid. So we have seen it in very much detail. So I hope you would have, now you are feeling quite interested for studying this compound. Okay, it has so many different types of reactions. It has very different types of behavior as well. So we are going to study all those things in this chapter, in this topic. So without wasting much time, then let's start studying sulfuric acid. So friends, I have divided this topic sulfuric acid into two parts, the same like our previous chapters. So we are going to study its preparation. That is just only one preparation we have to study, by contact process, how we are going to prepare sulfuric acid, and that too also just simply the chemical reactions along with the conditions. That's it. No need to go into details. Okay, there is no need to study the contact process in very much detail. Now, apart from that, we are going to see some chemical properties, very much interesting chemical properties, like when it behaves as an acid when it is dilute, it behaves as an oxidizing agent when it is concentrated, as dehydrating agent when it is concentrated, as its non-volatile nature, right? The concentrated sulfuric acid's non-volatile nature. And lastly, we are going to see some tests for dilute sulfuric acid and concentrated sulfuric acid that you would actually understand if you would follow all these four chemical properties. It would be very easy for us. Okay, so a quite small chapter, a quite small topic, but yes, so many reactions we have to study. So it's very interesting to study these reactions of sulfuric acid. So now we would start from this first topic, that is contact process, the preparation topic. Okay, so now in this contact process, we have to just study the reactions, how we are going to reach our sulfuric acid. Okay, that's it, along with the conditions. Okay, so I'm just going to write this concept, I'm just going to explain this contact process to you in 4 steps. Okay, and those 4 steps are followed in the contact process also. Okay, so first one is simply production or formation of sulfur dioxide. Okay, so I'm going to write it here, formation of sulfur dioxide gas. Okay, so how we are going to form the sulfur dioxide gas? Very simple. Okay, we would react pure sulfur. Okay, we would take pure sulfur and make it react with oxygen, and we would get sulfur dioxide. As simple as that. Okay, but if you want to complicate things, or if you want some another method of preparation of sulfur dioxide, yes, we have another method as well. Okay, which is we would use sulfides, metal sulfides. Okay, here it is iron sulfide, and we are going to treat it with again oxygen, same way. Okay, just like this. And here what we would get is, we would definitely get sulfur dioxide gas. Okay, but along with it, okay, we would get the metal oxide as well. Okay, so sulfur dioxide and metal oxide. So metal oxide here we would get is Fe2O3, ferric oxide. Okay, So in this way we would get the sulfur dioxide gas. I'm not balancing the reactions, you can balance it on your own, it's quite easy, now you all know. Next is how we are going to make this sulfur dioxide, okay, convert the sulfur dioxide to sulfur trioxide. So that belongs to the second step, okay. So it's called as catalytic oxidation of SO2. Okay, now from the name itself you can remember the reaction. I'm going to tell you the reaction as well as the conditions as well. Okay, so see, we are going to convert this SO2 to SO3. So that's why we are oxidizing it. We are increasing the number of oxygen here simply. So here catalytic oxidation. So we are going to use the catalyst, and catalyst is vanadium pentoxide. Okay, or we also use platinum. Both, any one of them we can use. Okay, vanadium pentoxide or platinum. Now here catalytic is done, then oxidation, which means we are going to add oxygen, and of SO2, which means our another reactant is SO2. Okay, and yes, what we are going to get is SO3. Perfect. Sulfur trioxide it is called as. So here the reaction is taking place in such a way that it is a reversible reaction first of all. Okay, this reversible reaction along with this catalyst, and lastly the temperature is 450 degrees Celsius. That's it. This thing you have to remember. This is the chemical reaction as well as conditions for the second step. Moving ahead to the third step. Okay, now what we are going to do is we are going to take this sulfur trioxide, okay, and we are going to convert it into oleum. Okay, so what I would write is here, what we are going to do is actually that I'm going to write. Okay, so what would be happening here? Absorption of sulfur trioxide SO3, okay, in sulfuric acid, okay, to form, okay, just separate this two and form to form oleum. Okay, now what is this oleum? Oleum is this H2S2O7. This is oleum. So here what we are going to do, I have written it down. I'm going to take this SO3 and I'm going to make it dissolve in H2SO4. As simple as that. And what I would get is this H2S2O7 oleum. Okay. Now here you can see H2S2, right? And then O3, O4, O7. Okay. Here we are actually dissolving SO3 in H2SO4. We want actually our H2SO4, but in this process itself, see how interesting this process is. In the process itself, we are using the product which we want at the end, okay, for generation of that product itself. So that's the interesting part of this contact process. Now the last step is, now you would say, sir, where we have ended up, what is this role of oleum? Okay, why we want this oleum? Okay, so the last step will clarify that why we have reached this oleum is we are now going to make, or we are now going to obtain our sulfuric acid from this oleum itself. Okay, so I'm going to write just the last step here. Fourth step is dilution. It's very small step, dilution of oleum. Okay, we are going to dilute oleum with water. That's it. So I'm going to take H2S2O7 and I'm going to add water in it, and then I would get 2 molecules of sulfuric acid. That's it. And we got our product. Okay, so this is actually what is happening in the contact process. You need to remember only this much. That's fine. Okay, for your examination point of view also. Now let's move on to the chemical properties of sulfuric acid. Okay, so we are going to see the chemical properties of sulfuric acid, okay, but the dilute sulfuric acid first. Okay, so our dilute sulfuric acid, okay, behaves as an acid. Okay, behaves as an acid when it is okay. Or we can also say that sulfuric acid, when it is dilute, it behaves as an acid. Okay, and when it behaves as an acid, it reacts with this metal oxide, metal hydroxide, as well as metals. And we're also going to see the next another another compounds with which it is going to react, that is metal bicarbonate, metal carbonates, metal sulfides as well. Okay, so here in this slide I am going to tell you how it reacts with metal oxide and metal hydroxide. Okay, quite very interesting types of reaction, and all these reactions, okay, we have already seen, okay, we have already studied them in the chapter number 3, acid, basis and salt. Okay, the chemical properties of acids in that. So let's again revise it quickly, okay, and also study it, okay, for sulfuric acid as well. Okay, fatafat. So how it reacts with metal. So when it reacts with metal, just remember the general reaction, that's it. So concentrated sulfuric, the dilute sulfuric acid, okay, when it would react with metal, what it would give is simply metal sulfate and hydrogen gas is released. Okay, now how? Let's see. So I'm just taking a simple example. Suppose I'm taking sodium. Okay, so sodium, when it is reacting with sulfuric acid, it would form, see, Na2SO4, sodium sulfate, and H2 is released. Okay, simple, Na2SO4 and H2 is released. So balance the reaction on your own, that's fine. So this was the first one. Let's see the next one, metal oxide. And the general reaction for metal oxide and metal hydroxide remains the same. Okay, now the same logic, what it is, that this metal oxide and metal hydroxide, they are basic in nature. Okay, and we all know, since I have told you that dilute sulfuric acid behaves as an acid, right? So when it would react with this dilute sulfuric acid, this means it is reacting with an acid. So when base reacts with an acid, what it gives us? Simple, salt and water, as simple as that, right? So it would give us salt and water. So now let's take one example for metal oxide and metal hydroxide each. Zinc oxide. Okay, and yes, another one, zinc hydroxide itself. Okay, so zinc oxide, when it would react with the dilute sulfuric acid, it would form salt and water, right? So it would form zinc sulfate, right, is salt, you can see here, and then H2O, water. Okay, fine. Same way here, zinc sulfate, 2H, 2OH, 2 water molecules. Very simple type of reactions. Okay, now moving ahead to see the reactions of metal carbonate or metal bicarbonate, metal sulfide with our dilute sulfuric acid. Okay, so yes, but before starting this, one more important thing, okay, in the reaction of dilute sulfuric acid with metals, okay, it is dilute sulfuric acid can react with those metals which are above hydrogen in the electrochemical series. Okay, fine. So we all know, right, we have studied the electrochemical series in electrolysis chapter. Okay, so what are those elements? So I would just jot it down, okay, in the same order, like potassium, calcium, okay, then sodium, magnesium, aluminium, zinc, iron, nickel, tin, lead, hydrogen, okay, tin, lead, hydrogen, and then CuHgAg, okay, CuHgAgAu, Pt, platinum. So you can observe here, okay, that zinc, iron, nickel, and then tin, lead, hydrogen. So here above hydrogen, okay, all these metals can react with our dilute sulfuric acid and show this reaction, which would give metal sulfate and hydrogen gases released. Very simple. Okay, this reaction, all these metals would give us. Fine. So then moving ahead to metal carbonates and metal bicarbonates. So here very simple reactions are there. So metal carbonates and metal bicarbonates, when they react with our dilute sulfuric acid, okay, they simply give us salt, water and carbon dioxide. Here metal sulfides give us salt, water and sulfur dioxide gas. Okay, just one change. carbon dioxide, in place of carbon dioxide, sulfur dioxide, and metal sulfides give us salt and hydrogen sulfide gas. Okay, so I would just give you one example of each, how to form the salt, how to form the water. And yes, here the salt which are formed, okay, in all the cases, okay, the salt which is formed here, it's sulfate salt. Okay, just get this thing right in your brain, it's sulfate salt. So I would show you some reactions of this, starting from sodium carbonate plus sulfuric acid, dilute one. So it would give me sodium sulfate, water, carbon dioxide. Okay, in the same way, if I would write the reaction for sodium bicarbonate, it would become the reaction for bicarbonate. So sodium bicarbonate, sulfuric acid, sodium sulfate, and then water plus carbon dioxide. Okay, very simple reactions. Okay, the bicarbonate will also give us sulfate salt, and then remaining is water and carbon dioxide. Now, let's see the sulfite one. So sodium sulfite Na2SO3 again with H2SO4, it would give us Na2SO4, and what it would give again SO2 and H2O. Okay, while our sulfide, so I would take this example, ferrous sulfide. Okay, see Na2SO4 right here, and then H2O and H2O, and one O would miss, O would go from here, then what it would form, SO2. Okay, so in this way also you can remember the reaction. Fine. Na2SO4 and then H2O, SO2. Then moving ahead, FeS. Okay, so FeSO4, H2S gas. See, H2S gas. So again sulfate, but here H2S gas is released. Okay, so these are the simple reactions for this metal carbonate, bicarbonate, metal carbonate or metal bicarbonate, metal sulfides, and metal sulfide. Okay, so sulfide, this is sulfide, this is sulfide. Just don't get confused. Okay, sulfide means SO3. Sulfide means which means metal sulfide. Okay, so for example, here iron sulfide I have taken. Okay, copper sulfide. Okay, or zinc sulfide. In this way, sulfides are there. Okay, it is having S2 minus anion. We all know these things, and sulfite is having SO3 2 minus anion. Okay, this is the very basic difference which I hope you would be knowing. Okay, so now let's see the chemical properties of concentrated sulfuric acid. Okay, now first one is non-volatile nature. Okay, this is the first one. Now we all know that yes, concentrated sulfuric acid is non-volatile in nature, which means that simply it doesn't get volatilized easily, it doesn't get converted into its vapors easily. This simply means that its boiling point is higher. Okay, that's the reason it doesn't get converted into its vapor easily, and that's why we call it as non-volatile. Okay, this simple logic we already know. We have studied it in acids, bases, and salts as well. So, but I have just given you a recap here. Now, this non-volatile nature is actually used for preparation of volatile acids like hydrochloric acid, nitric acid, which we have already seen in the previous chapters, right? So here also the same reactions are there. Okay, exactly the same reactions which we are going to study, which we have studied already, we are going to study here itself. Okay, so simply the reaction with NaCl, KCl, okay, and NaNO3 and KNO3, okay, which we have already studied with the concentrated sulfuric acid. So I'm just writing here itself in the beginning only, here concentrated. So here all the sulfuric acid is concentrated sulfuric acid, concentrated sulfuric acid. That's it. Okay, and what products we get here? Okay, we get simply, now here in this case we have already studied NaHSO4. Okay, one H is gone, so NaHSO4, and what is remaining now? HCl, right? So NaHSO4 and then HCl. Okay, and this HCl gas we would pass on through the generating flask and all those things, and then we would make it then we would dissolve this HCl gas in water, and then we would get hydrochloric acid, right? So in this way we prepare our non-volatile acid HCl. Okay, now here the reaction remains same. Okay, so KHSO4 and then HCl. Okay, right? Same way, now here NaHSO4 and HNO3. Okay, so you can also follow my trick of remembering the reactions. Okay, again KHSO4 and then HNO3. Okay, that's it. These are the 4 reactions which we need to study in the non-volatile nature of concentrated sulfuric acid. Okay, now let's see the another property, okay, chemical property of concentrated sulfuric acid, which is it acts as an oxidizing agent. Okay, so first let's see how it acts as an oxidizing agent, okay, or why it acts as an oxidizing agent. Okay, so it's simply because when thermal decomposition takes place of sulfuric acid, okay, so I'm having this sulfuric acid, and when the thermal decomposition takes place, okay, it gives off nascent oxygen, okay, along with water and sulfur dioxide. Okay, so nascent oxygen, I am writing it in brackets. Okay, this is called as nascent oxygen, single oxygen atom. Okay, nascent oxygen means single oxygen atom, not O2. Now this reaction would help you to actually, okay, remember the reactions of concentrated sulfuric acid with carbon, sulfur and copper, which we have to study in our syllabus. Okay, so what actually happens is this thermal decomposition takes place and water and sulfur dioxide gas is, means here water and SO2 is formed along with the nascent oxygen, and this nascent oxygen oxidizes metals and non-metals. Okay, so now if the reaction, okay, that is the oxidation, okay, of metals and non-metals. For this we are seeing the examples. In case of metal only copper, in case of non-metals we are seeing the example of carbon and sulfur. Okay, so let's start with carbon and sulfur. Okay, so carbon, let's take it black. Okay, so carbon, okay, when it reacts with the sulfuric acid, concentrated one I'm talking about here. Okay, don't miss out this thing, concentrated sulfuric acid, because here the property of the sulfuric acid, which is an oxidizing agent, is only for concentrated sulfuric acid. Okay, dilute sulfuric acid doesn't show this oxidizing property. Okay, keep this in your mind. Clear? Now what is the reaction actually here? Okay, what would happen? Oxidation would take place of this non-metal. So carbon's oxidation would take place, then what it would form? Carbon dioxide, right? It would attach with oxygen. So see, it got oxidized, so it formed carbon dioxide. Okay, carbon dioxide. Okay, so carbon's part is done. Then the remaining elements are hydrogen, sulfur and oxygen. So what they would form is simply this H2O and SO2. Okay, so H2O and SO2. Very simple, very clear, this reaction. Similarly, in the same way, it reacts with sulfur and concentrated. It reacts with sulfur, okay, concentrated sulfuric acid. Now you guess the products. Okay, you can pause it here and you can just write the products. Okay, so what products would be? Again, sulfur would get oxidized to SO2, correct? But here, apart from that SO2, H2O and SO2 are also going to be formed. So simply the products are SO2 and H2O, right? Because sulfur would get oxidized to SO2, and here hydrogen, sulfur and oxygen would also result into H2 and SO2. So SO2 and H2O and SO2. So what are the products? SO2, right, and H2O, right? SO2 and H2O. Simple, very simple. So what would happen with copper then? Now, copper would also get oxidized, right? But here don't write copper oxide. Okay, you would go wrong. Here copper sulfate is formed. Okay, copper sulfate is formed, and rest is the same. That is, it would form water and SO2. Okay, clear with this? Reactions, okay, the reaction with non-metals like carbon and sulfur, and reaction with metal like copper. These three reactions we have to only study in our syllabus, okay, for the property of concentrated sulfuric acid as an oxidizing agent. Okay, now let's see the last property of concentrated sulfuric acid, which is dehydrating agent. Okay, concentrated sulfuric acid, it acts as dehydrating agent. Now this property is very, very interesting. Okay, the two reactions which we are going to study, which are given in your syllabus, that are first the reaction of concentrated sulfuric acid with copper sulfate crystals. Okay, so this copper sulfate crystals are blue in color. Okay, and yes, it is having this 5 water molecules associated with it, okay, which is water of crystallization. We obviously know this thing. Now what happens when our concentrated sulfuric acid, okay, we treat this copper sulfate crystals with concentrated sulfuric acid, is the blue color of this copper sulfate crystals, it just goes off, okay, and what we get is white colored copper sulfate, okay. Now we call this copper sulfate, okay, which is now free of that water of crystallization, so we also call it as anhydrous, okay. An means water is not there, anhydrous, so not having water, okay, anhydrous copper sulfate, okay, but it is white in color, so it turns this blue copper sulfate crystals white. And how it turns? By removing the water, okay, from it. So when it acts as a dehydrating agent, sulfuric acid, it gives off water as a product, okay. You just remember this thing in your mind, then it's very easy for you to write the reactions, to remember the reactions, and the reaction itself is very much interesting, okay. So I haven't written blue color because I have already used blue color to write the copper sulfate crystals. So yes, this is how copper sulfate crystals are being attacked, or this is how copper sulfate crystals react with concentrated sulfuric acid. Concentrated sulfuric acid just removes the color of this copper sulfate crystals, okay, makes it white, anhydrous copper sulfate, okay, and gives out water, 5 water molecules. Very, very interesting, right? Again, the next one is we have to study the reaction of our sulfuric acid, concentrated sulfuric acid, with sugar, okay. So here we are going to see cane sugar, okay. Cane sugar is nothing but sucrose, okay. So starting from its molecular formula, so see, sucrose molecular formula is C12H22O11. Now how you would remember this? I will tell you. This sucrose is made up of glucose and fructose, okay. Now no need to go into this much detail, but in order to remember the formula, I'm going to tell you the simple trick. What you do is, both glucose and fructose are having molecular formula, this C6H12O6 and C6H12O6, okay, both glucose and fructose. So what you do is you add them, okay, and while adding, you take care that you remove 1 water molecule from them, okay. So what would happen? See, C6, it would be C12 simply, okay, because we are just removing hydrogen and oxygen. So carbon would add up as it is C6 and C6 C12, 12 atoms of carbon, then 12 and 12 atoms of hydrogen would become 24 atoms of hydrogen, but then we are removing 2, so it would become 24 minus 2, 22, so H22, and then O6, O12, but removing 1 oxygen would result into O11, so O11. So see, we got the formula for sucrose. In this way you can remember C12H22O11, and this way is actually the very correct method, okay, means logical method. Also, when you would study carbohydrates in detail in your higher classes also, you would understand that yes, okay, sucrose is made up of glucose and fructose. That's why we are used this method to remember the formula. Now moving ahead, I have told you the simple trick to remember the formula. Now let's see the reaction C12H22O11, cane sugar, okay. Now this reaction is very much interesting, okay. You can observe on YouTube as well. You can just see the reaction of cane sugar with concentrated sulfuric acid, and what you would observe is that I'm going to tell you here, okay. You would observe a black spongy mass of carbon, black spongy mass of carbon, okay, is rising out, okay. So if I'm taking a beaker and I'm having cane sugar in it, and I'm adding the concentrated sulfuric acid into it, okay, so what I would observe is like this black mass of carbon would rise out, okay. Along with it, okay, steam is given out, okay, like this. So from this we can just figure out very simply that this reaction is exothermic, okay, correct. Now one more interesting thing is the carbon which is formed here, okay, in this reaction is very pure, very pure. Okay, and we call this carbon as, since see, name is cane sugar, right? Reactant is cane sugar, so name is sugar charcoal. Okay, so this carbon is called as sugar charcoal, which is obtained in this reaction. Okay, so yes, lastly, when this reaction happens, we say that our sugar is charred. Okay, it got charred. Okay, so quite interesting reactions, and yes, very important as well from exam point of view, because some questions are also being asked from these reactions. Now, the last topic of this chapter is we are going to see some tests for dilute sulfuric acid and concentrated sulfuric acid. Okay, so before that, the tests are based on the properties of dilute sulfuric acid and concentrated sulfuric acid. So from the entire discussion till now, you would have observed that yes, concentrated sulfuric acid is definitely, it is showing, right, oxidizing properties. We have seen the examples of the reaction with non-metals and metals. It is also showing the property of dehydrating, okay, other substances, or as a dehydrating agent. It behaves as an oxidizing agent, it behaves as a dehydrating agent. Okay, but both of them properties which are shown by the concentrated sulfuric acid, they are not shown by the sulfuric acid. Dilute sulfuric acid, sorry. Okay, dilute sulfuric acid is neither oxidizing agent. Okay, it cannot oxidize. Also, it cannot behave as a dehydrating agent as well. Okay, now these two properties only we are going to make use of, and we are going to see two tests for dilute sulfuric acid and concentrated sulfuric acid, so that we could distinguish them. Okay, that yes, this is dilute and this is concentrated. It's quite easy. Okay, but still, let's do it. So, first one is, I would take this property, dehydrating agent property. So since dilute sulfuric acid is not acting as a dehydrating agent, so when we would make it react with cane sugar, okay, dilute sulfuric acid, so what it would give, it won't dehydrate cane sugar. Okay, it won't dehydrate. But in the same manner, we have just now seen concentrated sulfuric acid, yes, it would dehydrate cane sugar. Okay, it would dehydrate, it would give us a black spongy mass of carbon which would rise out, and all those things, all those observations you could observe here in case of concentrated sulfuric acid, and here in case of dilute sulfuric acid, the cane sugar would remain as it is. Okay, it won't show any changes, right? So this is the first distinguishing test. Another one is based on the oxidizing property. Okay, so dilute sulfuric acid, if I would take copper, okay, so it won't show oxidizing property. Instead, we know that dilute sulfuric acid reacts with metals and it gives off hydrogen gas, okay, along with metal sulfate. But we also know that dilute sulfuric acid reacts only with those metals which are above the hydrogen in the electrochemical series, and copper, absolutely, it's below hydrogen in the electrochemical series. We have just now seen the electrochemical series a few slides back, right? So just below hydrogen, it's copper, and it doesn't react with copper. Dilute sulfuric acid doesn't react with copper. Okay, so it won't show any reaction with copper. But here, concentrated sulfuric acid, yes, it would definitely react with copper, and we know how it reacts. Okay, we have seen the reaction of concentrated sulfuric acid with copper. Okay, the oxidizing property, in which it would form copper sulfate, and along with copper sulfate, it would form water and sulfur dioxide. Okay, so see, water and sulfur dioxide. Now, you would say, sir, how we could figure out that sulfur dioxide, this gas which is evolved, is sulfur dioxide? Okay, so yes, sulfur dioxide gas is having a characteristic property. Okay, what it does, it turns orange, okay, acidified. Okay, so I have written here sulfuric acid. So acidified K2Cr2O7, potassium dichromate, okay, acidified one. So this sulfur dioxide, what it does is, it turns this acidified, see, acidified potassium dichromate, which is orange in color, okay, into green colored substance. Okay, oh, wait a minute. Into a green colored substance. Now what is this green colored substance? It's actually the sulfate of chromium. Okay, so it is sulfate of chromium, and yes, in this chromium is having 3+ charge. Okay, so Cr3+, SO4 2-, right? So we would balance them so that we could write the formula, okay, of the sulfate. So 2 3s are 6, right? 6 plus 3 2s are 6-. Okay, so Cr2SO4 thrice, Cr2SO4 thrice. So this sulfate of chromium is formed, which is green in color, right? So that's why we are observing that sulfur dioxide gas is turning this acidified potassium dichromate, which is orange in color, into green color. Okay, and along with it also potassium sulfate and water is formed. Okay, clear with this reaction? So how we could distinguish between the dilute sulfuric acid and concentrated sulfuric acid? Okay friends, so let's quickly see some questions based on this sulfuric acid topic which are asked in your previous year exams. Okay, so I have just noted the year of the exam here, you can observe, and the questions are like this. Okay, so first one is write balanced chemical equations to show. So we just need to write the balanced chemical equations, and for whom? First is to show first the oxidizing action of concentrated sulfuric acid, right? Concentrated sulfuric acid on carbon. Okay, so this reaction we have already studied, right? In the previous slide you can observe here, see the oxidizing action of carbon. Okay, oxidizing action of concentrated sulfuric acid on carbon, right? Carbon dioxide, water and sulfur dioxide. Okay, these are the products and you need to just balance the equation, so you would get the answer. In the same way, the next one is behavior of sulfuric acid H2SO4 as an acid. Okay, when it reacts with magnesium. So when H2SO4 behaves as an acid when it is dilute, right? So dilute H2SO4, first we need to interpret what they are asking in the question and then we need to solve it. So dilute H2SO4 they are talking about, so that at that time sulfuric acid or H2SO4 behaves as an acid and when it reacts with magnesium. Okay, so it's very simple, we know magnesium and dilute sulfuric acid, it would give us the sulfate of the metal and hydrogen gas is released, right? So MgSO4 and hydrogen gas is released, right? You need to balance them. Okay, almost absolutely it's balanced itself. Okay, so then that's the answer. Okay, MgSO4H2 simply. Okay, third one is dehydrating property of concentrated sulfuric acid with sugar. Okay, so just now we have seen a few slides back. Okay, the concentrated sulfuric acid reaction with sugar, cane sugar, right? So C12H22O11, right? Cane sugar. What happens? Carbon and water is released and we get the black spongy mass of carbon, right? See, so cane sugar with concentrated sulfuric acid, carbon and water is released, and all this, and no need to now write all these things in the answer because they only want the balanced chemical equation, right? So you need to just write this reaction and balance it, as simple as that. Okay, moving on to the next one. Write balanced chemical equations, which means we have to write just a simple chemical reactions but balanced one, to show how SO3 is converted to sulfuric acid. Okay, and how in the contact process. So this also we have already seen, SO3 to sulfuric acid. Okay, so this means that we are reached to the point when SO3 is formed. Now here we know what we have to do is we have to dissolve SO3. Okay, like we have to take SO3 and make it dissolve in sulfuric acid itself. Okay, the next the first step, okay, from SO3 to H2SO4 is absorption of sulfur trioxide in sulfuric acid itself and we get H2S2O7. So I have told you already, this is the beauty of the process. We are using the product itself in the reactions so that we could get the product again. So this oleum, simply in the next step what we do is we just dilute it. So H2S2O7 plus water gives us H2SO4 sulfuric acid. Okay, now these two reactions, if you would balance it, your job is done, right? And moving to the next one, which property of sulfuric acid is shown, okay, by the reaction of concentrated sulfuric acid with carbon. Okay, so again the same thing, concentrated sulfuric acid with carbon, which property it would show. Just now a few slides back only we have seen the question. Here we have written there they are asking us to write the balanced chemical equation. Here they are asking which property is shown by the concentrated sulfuric acid. Now we know carbon is oxidized, right? So the property which is shown by the concentrated sulfuric acid is oxidizing property, right? Or simply you can write it is acting as an oxidizing agent. Okay, so with this we have reached the end of this video, and I hope you would have enjoyed learning with me. You would have understood all the concepts related to the sulfuric acid. We have studied so many reactions of sulfuric acid. Okay, but please do let me know if you have some doubts in the comment section. I would be waiting for the comments. Okay, and yes, as you all know, learno matlab free hai par best hai. So stay tuned. We will see the next chapter in the next video. Till then, bye bye, keep studying and have a great day.